know the logic also.
Yeah. So yeah, it all depends on the interpretation. So it is like that. You are putting some input value, it is giving the some output value. So it will, you don't know what is happening under the hood, no, then it's a black box method. And if you know what is happening under the hood, then it's a white box method. So the biggest advantage of decision tree is that we are able to visualize like how it is splitting, okay, how the splits are happening, okay. So that is the biggest advantage of decision trees, okay. So that's why it is a white box method. For example, here the course is designed in such a manner that MLT is about like a white box method and MLP is like a black box method. Here you just simply just put that yeah, svm dot fit, svc dot fit, svm dot svc dot fit, and yeah, then dot predict. So you don't, I mean, you are simply using the libraries and solving that. But yeah, ultimately, since you have learned, you know, like what is happening under the, that's a different thing. But yeah, so eighth question said where a very high value of minimum number of samples, minimum sample split or minimum sample leak will prevent the data from learning. So what do you think that? Hello. So what is your perception about this question? See, minimum sample split or minimum sample leaves. It is talking about the minimum sample split would be the last, second last split, and minimum sample leaf would be the last split. Okay, I mean, yeah, last node. Yeah, so it is like that. So it is what the question is saying, that very high values of this one. Okay, so what does it mean? I mean, say let's say we have 100 number of samples. Okay, so this is the I mean, yeah, this is the total samples. Okay, so let's say we took decisions, we created this one, then again here. Okay, so let's say here we had two values, here two value, here 4, here 6, here let's say 10, here 20. I mean, it's 10, then it's 20. So let's say I'm setting that minimum sample split we need as a I mean, yeah, we need 10. Okay, so this only this split can happen. I mean, from here we can't split because the minimum sample split value we are it went beyond 10. So okay, so what we'll do here is like we increase the high value of minimum samples, no, then it will reduce the size of tree. So what will happen ultimately when we set it as 100? Okay, so then only one split can happen. Or let's see, like we set it as like a leaf, a minimum sample leaf as 100. So I mean, there won't be there no split will happen. Okay, because this is the minimum number of samples we need in a leaf. Okay, so what will happening? So this question is saying that a very high value of minimum sample split or minimum sample leaf will prevent the data from it. So yeah, that is what it will happen. That is what will happen. I mean, once you will increase the value of minimum sample leaf, so it will, yeah, reduce the size of tree. And at a certain point, when minimum sample leaf equals to, when minimum sample leaf equals to number of samples, no, then no split will happen and your model won't get, I mean, yeah, it will prevent the data from learning. Okay, so I think you got the clarity.
Yeah, so basically we can say that flatter the tree, lesser is the learning, and deeper is the tree, more is the learning.
That's true.
Okay.
Yeah, yeah, more is the learning, and that there are high chances of overfitting also.
Right.
Sir.
Yeah.
Hello, sir. Sir, before you go to the next activity session, can you please explain the sixth question with an example, if you can?
Pick 10 example. I mean.
Sorry, sir. Sixth question, sir.
So this one. So it is possible to use the feature variable twice if it is of continuous form. So this one you want to explain. This
yes,
one
sir. Yes, sir.
Okay. So I think I need to make one example. Better, it would be better if I take some data set only. I would say that. So can we push this one to the end, because as of now none of the questions is coming directly in my mind. Okay.
Okay,
So,
sir. Okay, sir. We can do that at the end.
yeah. So because I also need to think like which data set which I have to take and yeah. Okay, let's move to the next one. Just why it is taking so long to. Yeah, I got logged out. Now we'll go a little fast because I spent a lot of time. Okay. And once and the end events when time will be there, then we'll go. Okay, so we have imported California housing data set in SQL. We observed that the features have different scales and decided to use standard scaler for scaling the features to some range. Is our approach correct? Okay, so let's see the approach. So first approach says that we should definitely perform pre-processing and scale the feature before training, otherwise our prediction may get impacted. We may choose, second option say that we may choose to ignore scaling as decision trees, have inbuilt methods for scaling the data. Okay. We choose to. Oh, so second option says that decision tree has some inbuilt method to scale the data. Okay. But the other option is saying that we may choose to ignore scaling as decision tree do not require a feature scaling. So which one do you think is correct?
Third is correct, sir. And third is correct. Absolutely.
Yeah, that's
second is incorrect.
Okay.
It doesn't require scaling.
Okay. Yeah. The second option is saying that it has some inbuilt method for scaling. That's why we don't need it.
So only third is true, I think.
Yeah, that's true. I mean, yeah, only third is correct. So first is saying that we need scaling. Third is saying that we don't need scaling because it has inbuilt method. Third is saying that we ignore scaling because it doesn't need any scaling. Yeah. So third one is correct. So, and I would suggest, one thing here. So basically many times you guys ask like, some question, which algorithm should we use in this case? So see, these ensembling methods are works very well with the classification data set. So always try to use that one. And there can be some cases like when you will do the scaling, here your model accuracy will little lesser if you avoid. I mean, let's say you train your model after scaling and you tried your model before scaling. Okay, using this recent tree. So there can be cases like where you are getting better accuracy if you don't scale. Okay, because it's not dependent on the that scaling, but it can impact your accuracy score. I mean, even if that sorry.
Any example?
I would again say that you have to take the data set and you have to cross check by yourself. I mean, just take some data set and you just do like first you do the first you do this one. I mean, use scaling and use different scaling and just try what is the output you are getting. And sometimes you see this is what I'm saying that a few people have said that I mean they were trying the scaling. I mean, when you participate in some hackathons, you try different methods. Okay, so
we should never scale for this.
Yeah, I would suggest never scale. So second question said we have loaded California housing data set and using the scale.
So I have a question regarding scaling.
Yeah, see.
Oh, so what you were taught that most linear models have assumption of Gaussian distribution.
That's
now if we scale as per the standard, I mean we scale as per the Gaussian, will it lead to better fit?
Are you talking about this one?
Any linear model, if I do the pre-processing, I don't use any other scaling method, but I use the Gaussian scaling method.
Which one?
the standard normal
Okay.
scaling method. So if I use that scaling method, will I get a better fit? Because
Yeah.
the assumption of the linear model is that the distribution is Gaussian.
See what happens, I would say, tell you. So basically what happens is, no, I mean, see, let's say we have something like age, height, okay, and weight. You are predicting the weight based on age and height. Okay. So what will happen? I mean, the range of age would be something like 0 to 100. Okay. The range of height would be around somewhere, let's say make it as a 20 to 100. Okay.
So
So then
that I
height,
understand, sir. The scaling is necessary. That I understand.
yeah, yeah.
That, but I'm saying which scaling. So if instead of min max, I do the standard scaler, will it give
Yeah.
me a better fitment or it doesn't make any difference?
See, again, I would say in this case, it depends on you. Okay, but yeah, basically we use. I also use that this one only. I mean, in most of the cases, we use this one standard scalar only, and sometimes yeah, basic. This is not that data is non-distributed. Assumption is that the error is non-distributed. Yeah, and here see what we do here is like as of now I'm also not able to recollect any, I mean, any particular advantage of that. One advantage I can talk about that is standard in between standard, I mean standard scalar and this one min max scalar is like a min max scalar. You can set the range. I mean, you can, this can help you to set the, I mean, set the range. I mean, if you want to distribute your data from -5 to 5 or something like that, you can do that. Here you have liberty for that, but here you have liberty like your data set will be between 0 to 1. It is like that. So you have to think here like, can you get some advantage if you distribute your data between -5 to 5, something like that.
Okay.
In that case, min max scalar can be useful. But otherwise, I'm also not able to recollect any example right now. Okay. Yeah, but in most of the cases, I don't. Yeah, yeah, I don't. But the thing, basic difference is this one only. I mean, you have to recollect exam. I mean, you have to think about any cases like where you have to set your data set range something between this one and this one. So if you
Right.
have the issues, then you can do that. Okay. So yeah, here in the next question. So this, as you said that, yeah, this one is correct only. Okay, so in this second question, it is talking about we have loaded California housing data set using skeleton tree, yeah, this regression for training the model. We get the so in the figure 2. Okay, with value of different value of tree depth. Is it possible to get a lower testing error if tree depth is checked for some values greater than 20? So okay, so they are saying that, yeah, once you go beyond this 20, so can you get some uh, lower testing error? It is like that, no? So basically what will happen here is like once you go beyond this optimum value, no, your training error will decrease and testing error will always increase. It is like that. I mean, you are going to overfit your model. So I would is it possible to get a lower testing error if the tree's depth is checked for some value greater than 20? So yeah, it is saying that when your tree depth is greater than 20, then you can get I mean, can you get that lower testing error? Okay, from lower from this one or that one? Okay. So yeah, so what do you think? Just say by seeing the graph, that is a good thing. Hello. Anyone just try, and I will tell you one thing. Yeah, hello. Anyone just try? See, in general, what happens? No, I will tell you. I will talk. I can argue in this question. I mean, the both ways. Okay. First argument will be like that. See, in general, what happens? No, when you go beyond this one, I mean, this optimum value. So your training error will decrease further, and test error will increase. So basically, after beyond this optimum value, your training error. I mean, your model will start overfitting. Okay, so obviously that's why your testing error will increase from here. Okay, but it can happen. I mean, let's say somehow you took after this point, I mean, yeah, let's say it is 20, so somehow you took some points, I mean some samples from this one only, and that is available in your test set. So obviously for that one, your I mean, you will get the lesser, I mean, you get the lesser error. Was I? But yeah, in general, that testing error will increase only. In general, testing error will increase, but it can, if you can change the testing error. No, if you talk about that, yeah, we have already decided this, yeah, this is your training error, this is your testing error, and based on that, you are getting this graph, and you are decreasing the depth from here. Then in that case, yeah, testing error will increase. But let's say like we can, if we can modify our testing, if we have made the model from here, and it depends on us that what testing value we will give, then it depends, it's a completely depend on the test data set. Yeah, it's a like general assumption that yeah, testing data will follow this pattern. But I mean, there are very high, very low chances of, I mean, getting the lower testing error. But in the most of the cases, testing error will increase error. From here it will increase only because the model will get more specific towards that data set. Okay. Anyone, anything would like to ask? Just try. The default values for the parameter controlling the size of the trees. Okay, yeah, as you said that max depth, minimum sample leaves lead to fully grown and pruned trees, which can potentially be very large for some data sets. To reduce memory consumption, the complexity size of the trees should be controlled by setting those parameter values. Yeah, that's true. I mean, by setting this parameter value, we can control the size. That is what it is. To reduce memory consumption, yeah, complexity and size of the trees should be controlled by setting those parameter values. Yeah, that's true. So third question say, fourth question say, choose the correct one. If there are less number of samples, descent tree will underfit. If there are less number of samples, descent tree will overfit. So what you say? Hello? Are you guys listening or what? Hello? Hello? Yeah, it's okay. Yeah, so as I talked there, yeah, if you have less number of samples, the descent tree will overfit. Okay. So let's go to the activity question 9.3. I'll go a little fast because I have to cover practice questions also. So yeah, the first question says that by limiting the height of the descent tree, what happens to the variance of the descent tree? So what will happen? I mean, once you control the height of descent tree, the variance will increase or decrease. So
Increase.
yeah, sorry.
Increase.
So basically, what I'm saying that you are reducing the size of tree. So what do you think? Whether it will increase or decrease? See, more, as we talked in the first question also, in the first activity session, yeah, in 9.1, that it tends to, the decision trees have a tendency to increase the variance. Okay. So more split will happen, more variance will be there. I mean, you think like more split is happening. So more will be the, I mean, the more will the number of splits, so more will be the variance. Okay. So so if you control this height, no, just you reduce the height, then yeah, variance will decrease. Okay. Because you can think about like that only. Like more will be the, I mean, more with the size of tree, more will be the height of tree, more overfitting will happen. So overfitting means high variance. Okay. like that also you can think. I mean, yeah, reverse or yeah, that you can think like that. Okay. So what can be the minimum number of samples in all leaves of a decision tree once the algorithm has finished learning on a data set? What will minimum number of samples in all the leaves? Minimum number of samples can be one. Yeah, because at least one sample should be there in the leaf node. Okay. So the third question is saying that which of the following may help you observe the correlation among different features of a data set? Notation and DF correspond to seaborn and delta frame. Okay. So all of these methods can be used to check the correlation coefficient. Okay. SNS dot heat map also help you to check the correlation, but yeah, it's just that it represents in a colorful manner. SNS dot pair plot also helps you to see the correlation, and DF dot correlation also like gives you the it gives you in the matrix form. But yeah, here the different only difference is that SNS gives you in the colorful format and DF dot correlation gives you in the normal matrix format. Okay, normal table format, I would say. Yeah. So it doesn't. Yeah, it's a general question. It is nothing. There is nothing specific in this question about decision tree. Okay. So fourth question says that choose the correct statement. So a pipeline applies a series of transformers sequentially. Second question says a pipeline applies a series of transformers in parallel. So which one do you think is the correct?
Sequentially.
Yeah, sequentially only. Because yeah, that's why you, I mean, you first you put the standard scale and all, then after you put the estimators. Okay, so it works like that only. So second, I mean, and it doesn't need, I mean, see, if you, it won't happen sequentially, you know. See, basically, we can take both example. See, if it won't happen sequentially, you know, I mean, then what will happen? I mean, here you are just changing the, I mean, you are improving the samples. I mean, you are using processing and you are using estimator both at the same time. Then obviously your estimator, you want, I mean, pre-processed data for this one. I mean, for your estimator. So that's why you need sequential step. Okay. But in column transformer, what happens? Like, I mean, I'm giving the, let's say, to transform this column. So it doesn't have anything to do with the second column. Okay. This column is independent. This column is independent. That's why these are called as independent variable. So you, if you do anything in this column, no, it doesn't depends on the other column. I mean, it won't affect your other column, other columns operation, I would say. Yeah. So that's why you can column transformation you can do parallelly, but yeah, these things you can't. I mean, yeah, things you can't do parallelly. Okay. So definitely one advantage of some parallel step would be that you will reduce the time. I mean, here also you can do the stepwise, I mean, yeah, stepwise approach, but it won't give you any advantage. I mean, because both the both the columns are independent. So yeah, you can if you do that parallelly, then yeah, you will take lesser time to do that. Okay. So yeah, so I think this one was all about, and now let's go to the 9.4. So yeah, first question says that when using scale and classifier, we can specify our stopping criteria by fixing the maximum depth level and tree maximum depth level that the tree will traverse. Okay, in case we do not specify this, the API will consider minimum sample split or minimum sample level before stopping. Okay, what are the default value of minimum sample split and minimum samples leave? Okay. So we talked about this one. So what do you think? What is the minimum sample split? What would be the minimum sample leave? Hello? Anyone? Just give it a try. I mean, yeah, I have talked about that. See, a minimum sample split should be 2. I mean, at least 2 samples is needed. Yeah, hello?
Yeah.
So anyone saying here or? Because if anyone saying that, just, yeah, speak loudly or otherwise, yeah. So minimum sample should be 2, okay, and minimum sample leaf should be 1. I mean, yeah, minimum value for leaf can be 1, and minimum two values needed for the split. Okay, then only we can split 1 1. And if it is 1, then yeah, we can't split 1 and 0. It is like that. Okay, so 2 and 1. Yeah, let's see. Which function do we use for exporting the feature names and threshold values used by SQL entities? Okay, so yeah, export text can you help you to export the all that? I mean, yeah, feature name and all. Okay, feature name threshold value. So export text helps you. And fourth question, we have loaded some data sets and used SQL dysentery classifier. We are using criteria as entropy and max depth as 3. We observe that value of entropy reducing as we go to a lower level. Can we conclusively say that the way of entropy, that the value of entropy will always go down as the depth of the tree increases beyond 3? No, that can't be correct. So it depends. I mean, yeah, there can be cases like after a certain split, yeah, you can get some lower values like that. Okay. And fifth question says, since distant trees are not impacted by different scales of features, they are also impacted by small variations in the data set. So as we read that, yeah, some changes in samples can, I mean, can completely change your descent tree. Okay. It is, although it doesn't depend on the, I mean, it doesn't depend on your scales, scaling of the data, but yeah, it highly depends on the changes in data set, changes in the samples of data set. You change the, you add or remove some samples, and yeah, there it can happen like, yeah, all the descent can be changed. I mean, yeah, because if you, the some initial decision gets changed, no, then yeah, all the further decision will change. Okay. So yeah, anyone, any doubt, anything? Okay, yeah, it's already perfect, but yeah, let's start discussing. I mean, this one. We can program. So, yeah. So first questions ask about that. Let's load the sklearn wine data set, then split the data set into train and test with 70:30 ratio with random state equals 1. Train using dysentery classifier with random state equal to 1. Okay. Another value being default. That's okay. So first question talks about enter the value of the score on training set, enter the value of the score on testing set, and third question says what is the level of depth of the train decision tree. Okay, so what do you think? I mean, see, first question is talking about the score. So can you say which score it will give as answer? Hello, anyone? Sorry, actually your voice is. We are not getting that much voice, and it's too less, so that I'm not able to hear you properly. It would be nice if you type the chat box, or yeah, or you can just speak a little louder. Both will work. Okay. So basically, it would be accuracy score. Okay. Enter the yeah, it will be accuracy score only. Okay. And for if it is, it would be if it would have been regression algorithm, then it would be R2 score, and yeah, if it is classification model, then yeah, it will be accuracy score. Okay. So yeah, what in the first step, what we have to do, yeah, you just load the wine data set and just split it. Okay. And after the split, just use a dysentery classifier and just fit it. Okay. So yeah, you can check your model score using train set, test set, and yeah, get depth can be used to help you to get the depth of your tree. Okay. So I think anyone has any doubt? I mean, yeah, it's a pretty simple question.
Yeah, it's simple. But I was trying the graded questions. There random state and other things are not mentioned for question 2 and 3. So I'm not clear how to.
Yeah. I'll tell you that that's a mistake
Okay.
from our side. Okay. So
Okay.
I also observed. Yeah, I think you only first raised the issue in MLP week 8, no? Yeah, please. Yeah.
No, I have not raised it, but yeah, sure.
In MLP week 8 side.
Sorry. Yeah. Okay.
Yeah.
I
Yeah,
remember now.
Yeah, so that's why I'm saying that, yeah, it's a, yeah, we have missed, we haven't provided that that value, random state value in the question. So yeah, actually last time the what happened, no, I will tell you the truth that we had some interns, okay, and due to, I mean, some but I mean, I would say that due to some tight deadlines, the peer review didn't happen that much. Okay. So that's why, and yeah, it depends on the students also. Like last time, people didn't ask about this. So yeah, we thought, yeah, that's correct. Yeah. So once someone solves in the question, no, then this is that, then they see, then he sees that, yeah, this is missing, that is missing, that is completely, that is we need, that is the data we need, and the thing, yeah, there were these things were few things were prepared by the some interns, and yeah, they missed this few things, and we also didn't do that much review, okay, because both courses were going together. And
Yeah,
this
okay.
time, yeah,
As long as we make the correction, that's fine.
yeah. And yeah, it see, ultimate agenda is to ultimate agenda is that you have to learn, and I think that you have done, that's why you are getting the answer. And
Yes.
Actually, sir, it is very disappointing to see this happen every time in every week and again in the OP.
Yeah, that's true. That I would also.
Like I also went through like, you know, every code, like every like the first couple of times it was okay, but like it's a very bad learning experience, in fact.
I also agree on this one. Okay, so yeah, but somehow you have to, yeah, but we will do the one thing I can also promise that, yeah, these issues, yeah, your juniors won't face, that's for sure. And also, like, there would be, I mean, lot of changes will happen in MLP and MLT, especially in MLT. MLT will be re-recorded completely. MLP will be also re-recorded, but yeah, MLT will be re-recorded completely by some different professor. And yeah, in MLP side also you can expect many changes. I mean, many changes in the sense that, yeah, these issues at least that won't happen. So yeah, obviously that whatever is we are facing, that's a different thing. But yeah, we due to some constraint, we were also not able to do that. But ultimately, yeah, it's our responsibility to give you that. But yeah, that is what I would say. Because obviously someone spends time now and then he sees that, yeah, his answer is not matching. But yeah, one thing you can see, I would say, Bhupesh and see, if you want to mention that random state, no, I mean, yeah, your answer will be, I mean, if you see, in some questions we are not giving the option, so that's a different thing. I mean, yeah, there obviously you can structure, but if you have given the options, no, your answer will be pretty closer to that. I mean, the original answer. So let's see, in the MLP we get, I think you would have been getting answer closer to that one, only, closer to the options only. Am I right? Hello?
See,
Yeah, it should be closer. Otherwise, there is no means the model is not valid, right? If
Yeah.
random state is affecting the value, then yeah, there is something wrong. So obviously, the different random states should not impact the values too much. It should be close.
Yeah, that is what I'm saying. Yeah. So yeah.
Yeah, like it's less of an issue in graded assignments, and like even if like it's 10% credit, like that, it doesn't really matter that much. But like what happens in OPP is that, at least for me, like I had two exams. I had like MLT also right after, so
Okay.
it'll affect even the questions. The disappointing part is that because of these problems, you don't get to do the things which you actually know pretty well. And that is very disappointing.
Agree. Because see, yeah, confidence goes down. I also say that, yeah, there are flaws in this evaluation process. Let's see, because see, ultimately, you can expect some changes, because yeah, as somewhere mentioning, someone was mentioning in the discourse that, yeah, since now we would have this one, I mean, MLP project. So yeah, we can change some pattern in this in this OPs. But ultimately, because ultimately it leads to your marks, final marks. So yeah, we have to do some changes. So basically, the mistake was on that question. No, I mean, like how many mistakes were there? I mean, whatever I felt that, yeah, that's a proper mistake.
I think the list Jaydev pointed out is very accurate. Like the 5 things, starting from RFE, a one-hot encoder. Then there's some typing mistakes, and like I think a
Yeah.
random state for one of the questions was not provided.
See,
And
yeah, just say, please say.
that is it. I think that list was very accurate.
Yeah, see, in that list, yeah, I would say that which will which were the bottleneck. I would talk about that. See, a few things were there.
One-hot encoder was the bottleneck for me.
Yeah,
actually.
that is what I would say. That was the bottleneck one. I mean that one-hot encoder, because all the question depends on that. But ultimately, if you see that many questions were the many questions in the end and all, like many questions were based on the training data only. But yeah, and also like the accuracies, if you I mean the score, if you check that RT score and all, like if it is 0.97, if you change some decisions, no, then it won't change that much. Okay. So but still, yeah, that was the bottleneck one. And the second one at RFE, where the linear estimator was not mentioned. Actually, you had to use linear regression estimator, but that was not used. So, but ultimately, like we had seen that announcement, no? Have you guys not got or what?
No, I haven't received any announcement.
I mean, like before around 9 a.m. like we have sent the announcement, like yeah, linear regression estimator is missing. And
through what channel?
I think see what happens, like whoever is the proctor, no, they got the information. So it depends on.
But like it was not passed on to me at least.
Yeah.
Even I did not get it.
Yeah, sorry.
Even I have not received any announcement.
Yeah. So it, I would say, yeah, that it depends on that. I would say that particular proctor, like whether he didn't convey you. Yeah, that is the thing that happened. So see, first thing I would say, yeah, you see in the again you may think like it's an excuse, but yeah, ultimately I'm saying what I am conveying is see. Mistakes are bound up, and there can be some mistakes. I mean, in any exam, you can see some mistakes, like typing mistakes and all. So what happens, like there, see, you guys have like large number of audience, more number of audience, more peer review happens. Okay, so yeah, you will get to know that issues. But the thing is like how we should be able to rectify that mistake. See, in the IIT's GATE exam and any exams, like you see 3-4 questions gets removed. Okay, every time, because due to that only. But that's a different case. But here I will talk about in our courses. Like, see, what we see here, like if you see that some particular issues, no, just directly convey it to the just see that random state value as you talked about. That's it, and that random state value was not mentioned. Although you will even without random values, you will get the I mean your answer will be correct only if you haven't used that random value. Even after that, your answer will be correct, or you could have used random state which is earlier mentioned. Okay, 32, 42. But still, I would say, see, if you are seeing this kind of confusion, just convey it to that proctor. Okay, he will you will get the answers at that time only. But yeah, and the thing what we should do, I'm talking about now our mistakes. See, that is like that we missed. Definitely, we missed that. And this thing, I mean, I'm not worrying about this kind of mistake. Personally, I'm saying that this random state and all. But yeah, that one hot encoder and that linear regression estimator that was not mentioned. That we should have. I mean, yeah, we should solve that one, and it should be conveyed properly to the each and every student. Somehow we were not able to do that, because yeah, since many students see, I only conveyed that to announce that to all, because some student were asking. Okay, so yeah, but I think yeah, we were not succeeded in that. I mean, not every one of you got that announcement. No? So yeah, that's an issue, and definitely that question will be removed. That's for sure. And that one hot encoder is also, I would say. But in general, I would say, in general practice, I would say that definitely just as soon you see any kind of issues, no, because see, you will face these issues. It's just that yeah, here we have more number of issues this time. I mean, that I agree. I mean, we had more number of issues this time. So just ask the proctors. Okay, so what will happen? No, I'm like, I will tell you the process. What happens? Like once you ask the proctor, no, that one. So he just conveys to us. Okay, so when he conveys to us, no, then maybe we can see that yeah, definitely that is missing, or that is this is missing, or that is missing, something like that. Okay, so you can get immediate response. Okay.
Ask the proctor during the exam.
Yeah, you can ask for proctor. Yeah, during the exam only.
But
I mean,
that
yeah.
will consume a lot of time because we I mean, during the rush of the hour, you are yourself not sure whether you are right or not. So you can't validate. Right?
Yeah. I mean, see,
Yeah, that is a real issue.
Yeah.
I also had the same thing. Like I went into, I thought like I'm doing something wrong in my hot and powder and one hot and powder, and like like at least for somebody who is not very experienced in this, you can't tell if I'm doing wrong or
Yeah.
like the question is wrong.
Yeah.
Right.
I agree. See, it depends on the type of questions, I would say. Yeah, see, as you talked about that one, I mean, that random state, that you can directly say. Okay, and this one, linear regression estimator, that also you can say, no, like, I mean, RFE, you need estimator, otherwise the algorithm won't run.
Yeah. The simple things we can point out. Yeah, sure.
Yeah, those things you can point out. But yeah, that one out including, I agree.
What about this? Someone from faculty also takes the exam along with students.
Someone?
Someone from faculty also takes the exam along with students.
That would be a better thing, I would definitely say.
Yeah.
Seriously, I mean, I agree because yeah, we will be able to see the problems. But as I told you, I mean, there are few constraints which I can't convey. I mean, see, as you said, no,
It's
I mean,
fine. I think we can move forward.
Yeah, sorry.
We can move forward with the lecture.
Yeah. So see, the thing is, as you talk, no, I mean, we also see like there are things like which these things are, there are some mistakes and there are some flaws, but ultimately we are also not able to rectify that. There are some constraints. So that is what I'm saying. I mean, the constraints are like, yeah, you are doing this task, then some other task. So in these things, yeah, those smaller thing gets missed. But ultimately, it's our responsibility to do those things. So we will do that. And next time, let's see. I mean, I'm in favor of doing that thing on there. I mean, I'll request others also to. Yeah, I'll try to convince others also. Let's say use 3, 4, 5 data set. I mean, yeah, 4, 5 days. Now also we have 4, 5 data set, but there would be questions of like 4, 5 groups. I mean, the first four question would be on this data set, and second 4, 5 questions would be on that data set.
That is more sensitive.
And yeah, to do the changes, what we'll do, for different batches, the different. I mean, the first 4 question is based on V1 data set for first batch, and for first group. But for second group, the first 4 question would be based on V2 data set, something like that. Because so that at least if you miss some questions, then you lose. 20% marks only. Okay, and in that too also, if you if some mistake is there in the question, so you have to worry about that 4, 5. You can skip that 4, 5 question and you can try other questions like that. That we'll try to convince that. Let's see what happens. Because ultimately it's a group. It's a group's decision. So, but yeah, that would be a better thing. I mean, in that way only, like we can remove this error. I mean, last time also what happened in OP1. OP2 was pretty smooth. OP2 we didn't had any mistakes or anything like that. So, but OP1 what had happened? No, I mean, the OP1 what happened? I mean, there were some redundant information. Due to that, people got confused. Okay, I mean, the questions were written something like that: drop the categorical variables and do. Drop the category also and take 3. Take 3. 3 variables name was something like 3 variable name was mentioned there. But what was happening here? There, no, I mean, you had 4 variables after dropping that. In the last step, you had 4 variables. So yeah, that was it. And due to that only, I mean, yeah, that question were around, I think 17 or 20, something like at that question right there. So yeah, people started getting different answer from there. So, but yeah, ultimately that was true that almost all the answers were in the range only, but ultimately that was also a mistake. So this evaluation process definitely has issues. That I would also agree. because one time we can think, yeah, it's a mistake, we can rectify it. But this time we can definitely think like, yeah, it's not just about the mistakes, and due to one mistake, yeah, the people's experience can be very bad. So I think, yeah. Or any other suggestions if you guys want to give, then you can also give. I mean, if you have some better evaluation process, if you can suggest some better evaluation process, that would be also, I mean, yeah, we can at least raise that. Hello. Yeah, I think this question is done. Let's do the 4 to 6. Okay. So in this question also, like, it talks about load escalants wine data sets, split the data set into train and test with 70:30 ratio with random state equals 1. Train using decision tree classifier with random state equals 1. And the following parameters: use criteria as entropy, use splitter as random, default is best, max depth is 3, minimum samples required to split equals 4, use minimum impurity decreases as 0.1, train the model and compute the score on train data. That same thing. I mean, mention all the things whatever is given in here, and just use dot fit it. You are ready to. Okay, so they have plotted the tree. That's a different thing. Okay, so I think, yeah, more or less we covered the all the things. If someone wants to, I mean, okay, let me stop saying this game. Okay, if someone wants to speak something or talk about something, you can ask. And because you can say that for which question the random state was not given. Hello.
I think it's one of the red questions. It was mentioned as RS when RS was not defined.
Oh, that I got to know. I mean, yeah, that yeah. So I'm talking about week 9 grade question. So if you will use the C for RS, actually what it was mentioning, like initially they have mentioned, no, like take random state RS equals something, well, 32 or 42. So you have to take that only. So that was completely fine. I mean, if you would have any RS random state value, you would have taken, or without that also, like your answer would be in range only. So yeah. And I was talking about this one, I mean, week 9. And regarding MLP OP, we'll talk about that one hot encoder question and this estimator question. Okay, I mean, RF estimator. RF estimator, surely we will drop that. That's not an issue. And let's see about, we'll discuss about this one. I mean, that one hot encoding part. And we'll see that what everyone says. Okay. Yeah, so here just say about this one. I mean, in MLP week 9. See, for first 3 questions, random state they have mentioned as one. For 4 to 7 also they have mentioned random state value. Yeah, 4 to 7 they have also mentioned. I think random state is mentioned here. Hello? Hello, whoever it was, I mean, someone who was talking about this one random state value. Can you repeat, or can you? Let's say whoever has tried the questions, he can raise his hand or something like that.
Sir?
Yeah, please say.
Sir, in the beginning of the session, I like requested you to explain how we are viewing those mindset MNIST, that data set, that numbers. If you can explain that code.
Yeah, I can show that. I can show that. Okay. Yeah, thanks for reminding me. Yeah, so I think we can close the session. I mean, yeah, that I mean, by closing session means, I mean, yeah, MLP week 9. Yeah, Anyone who wants to ask anything about MLP week 9? Okay, so MLP week 9 is done. Yeah, thanks. Everyone, if someone wants to drop that, you can drop. Okay, I'll just. Yeah, let me see that that collab is with me or not. So how to visualize, how to see that data? That is what you are asking me. I think in
Yes,
one
sir.
of,
Yes, sir.
yeah. So I'll try to. I had used that exactly. So okay, yeah, in the meantime, I can ask them.
Sir, it is in week 8.
Okay, week 8. So had we did that or not? First question be that. So
Uh,
hello.
if you, sir, I don't know, like if you have done that in previous sessions or not. If you have, then you can just tell me the session name or point.
Yeah,
to
I also
me.
need to see the thing is like I also need to see like whether we had saw. I mean, in the one of the, I mean, in many of the sessions we had done that. I mean, to try to visualize that. I mean, in MLP week 7 SWI also I had done that. Like last time I had prepared I had only prepared that SWI. So in that one I had kept that, and here also I would have yeah. In this one also I think someone would have done in amnesia with amnesia they have done that visualization or not. I need to check. I'm just opening some few questions. Let's see. Okay, I'm just opening some of the collabs there. As much time, I think I am using. I have used that picture. Okay, I think yeah, I'm not able to find right now. I'll share it with you. I mean, or otherwise you can see. Okay. Let's see. I'm just trying to see the time. Okay. Let me also see. I think I'm one of the days. Okay, one thing you can do. See, hello. Hello.
Yes, sir. Yes, sir.
Yeah, you can ask in the Discord also. I mean, just now only I'm just searching. If you have time, then you can stop here, or otherwise, yeah, you can just ask in the Discord. Okay, I'll definitely say you that collab only. Okay, actually,
Discord, sir.
yeah, you can ask in the Discord. I mean, there also I can share the link. It's just that it's taking time. I mean, I'm also not able to recollect. I mean, in one of the session also, I mean, I had used that image data set. I mean, yeah, there were few pictures like in the last time I had made it. I'm not sure in week 7 or week 11 I had made it. There also I just tried to visualize that. I mean the images and all. I just plotted that, and after that, yeah, we did the operation.
Actually, sir, the problem is like I am not understanding the syntax that are used in this block of code.
Okay. So if you have that syntax, you can directly say that. I'll directly explain that. So was it covered in the week 9, week 7 or week 8? So are you saying that? I mean, have
No,
they plotted?
sir. Actually, sir, see, in week 8 for SVM classification, sir is using that MinSet data set.
Yeah.
MNIST or whatever the name is.
Yeah, amnesty. Yeah, it's okay.
MNIST data set. So, and this is not the first time I have seen this block of code previously also. Whenever professor uses this MNIST data set, he he views that data set using a special block of code.
Okay. Yeah. So can you refer like where this block of code is there? I mean,
I can just give you the screenshot or something like that.
Okay. Just share that screenshot, okay, so that I can explain in that position only. I just can explain each and every step, okay.
Okay.
Or if you want to share that, you can share just now also, or you can just tell me the address. I mean, can you tell the exact like where sir has plotted the data?
Okay. Yes, sir, that would be better. Yeah. So it is in which one thing? It is 8.2 lecture video 8.2.
8.2. Okay.
Yes, sir. And the time is 1:54, around 1:54, 1 minute 54 seconds.
Okay, 8.1, 1.4. Okay. So I think that, yeah. That collab, okay.
Yes, sir. That fifth cell number 5, whatever written in the cell number 5, if you can explain that, like.
Yeah, just wait. Codes tracker. Week 8. Okay. Week 8 here.
8 lecture video number 2.
Okay. Yeah.
And
yeah, I'm just directly opening the collab only. Okay. Got the collab link. Yeah, I'm just saving the screen. Okay. Yeah, this one you are saying, no? Hello?
sir, the screen is still like it is loading. Yes, sir. This one.
Yeah. See, in the first sentence, what you are saying that here, see, first sentence is setting you the parameters for like figure plot the plt dot figure size. So it is you are setting the size of this one. I mean the whole box. Okay. It is like a 10 cross. I mean 10 by 7. Okay. So it is like 10 by 7. Okay. So now what you are doing here is like for I in range of 15. Okay. So what you are saying that I mean you are iterating from 0 to 15, 0 to 14. Okay. So what I mean, yeah, see total, yeah, 1 to 4, 8 and 12. I mean uh, 5, 10 and 15. Okay. So you are
Yes, sir.
iterating through the 15 numbers. Okay. So yeah, this each and every box is there. Okay. So so what is in the this is the size of your final plot, and this is the subplot. Subplot side, what you are saving as a, this one is used to set the size of subplot. I mean this one. Okay. A
Okay.
figure dot add subplot 3 comma 5 comma I plus 1. Okay. So
Sir, yes, sir.
yeah. So so are you saying and getting the point? I mean, so this is a 3 comma 5 is the size. Okay. This one is 3 or
Okay.
this one is 5. Okay. This one is 3,
And
this
what
one
is
is
that,
5.
sir?
Okay.
I plus
I
1?
plus 1 is the position of that subplot. I mean, see, 0 plus 1 is the first position. 0 plus, I mean, when the I is value gets to 1, so this is the second position, this is the third position, fourth position, fifth position. So it will go from, like,
Okay.
see, I will start from 0. Okay. It is like that. Okay.
Okay.
So now the term is I am so. Okay. Okay. So here in this one, so this one is used to show the figure. Okay. This one is used to plot that figure. Okay. So what you have done here is like you put extra I. Okay. I mean that particular sample. I mean sample number 1. Okay. So whose
Yes, sir.
index is 0. Okay. So that you used,
So
and to
index 0 means,
index 0 means
sir, so
first sample. Hello.
first sample. So first sample will have 784 features.
First sample will have 784 features. Okay. Yeah, that's true. So the thing is, yeah, so yeah, all the 784 features, when you will use IMSO to show that one, it will print like that. I mean, so you are saying that what is that 784? Okay. So see, if you zoom in this one, okay, there are 784 black and white boxes, which is constitutively, which is combined together to make this figure, this 5. Okay. So here,
Okay.
just think about this 5 as a, I mean, since there were 784, no? I mean,
Yes, sir.
so 784 square root of 784. What? How much we get?
No, no, sir. It is actually 28 into 28. That will give us 784.
Okay, okay. So yeah, that is what I was saying. Yeah, 20 square root of 784. It is 28 bytes. So what is happening here is like there are 28 small pixels this side, 28 small pixels that side. Okay. So I mean,
Yes,
yeah,
sir.
yeah. So like that only we have all the pixels. So when you will use the IMSO to plot that, so that will give you the color of black or white, like that. So after plotting all the colors, you will see this type of figure.
Okay,
Did you
sir.
got my point?
Yes, sir. Yes, sir. Now I understood, sir. And axis of PLT dot axis of what is that doing, sir?
Which one?
Last last one, sir. The PLT dot
PLT dot
axis.
get seed map. Okay. So this one you will use to set the color. Okay. Just see this one. Okay. Just need to see. Okay.
Actually, the problem is, sir, like if we understand what is being done in all this syntax, then it is easier for us to remember. Otherwise,
That's, yeah, these things are missing. I agree. I mean, that's why it's, I'm telling that in the next in the next term there will be revamp, and yeah, these things will uh, or otherwise we will take also sessions. I mean, where we'll explain each and every line of code. Maybe some videos we will put like that.
that would be, sir, really helpful. Even if you like arrange those sessions after the term also. Let's say if, due to the schedule we cannot fit that in this schedule. After the term also it will be really helpful, because when we go to when we go for an interview, they might expect us to answer not in very depth,
Yeah,
but they
yeah.
might ask us few syntax or so. Then we will be able to at least explain them what this syntax or that is doing.
That's true. That's true. So if you guys want, then we can arrange that session. I mean, in this term also, if we have enough number of people like who want to learn that parameters. I mean, each and every.
Yes, sir. Yes, sir. I actually know like few people, like 5-6 people I know of, like, but again, like you might not want to do a session for 5-6 people, but
No, I mean,
I
so
can.
I mean, see, the thing is, see, if the peoples are there like who wants to learn, then we can arrange some on-demand session, okay, like that, where we can explain each and every line of code. So
That would be really helpful. That would be really helpful for. I can vouch for 5-6 people. I know 5-6 people. Those
okay,
who
so I think yeah. So
want to.
if you can watch for 5 seasons, then obviously there are peoples like. So okay, we can arrange one session. Okay, so let's talk about that one. Okay, so which week you want? I mean, yeah. So you, if you do you want for each and every week or what? Or I mean,
Sir, like we can when like when can you give this a session? You can give this session after our final exam also. Like we don't have any problem with that. And if you want to give that session before, you can do that. So just give us a time span like 10 days or 15 days. We will discuss among ourselves the problems we get. That problems only we will submit to you, and then you can prepare
yeah, that will be
prepare a
better. I mean,
presentation or
yeah, just
something.
directly submit whatever. Yeah, just submit the timing. I mean, yeah, lecture number or something like that. Okay, whenever you will,
Yeah.
whenever you guys just combine that, no, I mean, just explain these codes. Yeah, each and every line of code. Then we can directly take the session. I mean, yeah, we can
Because
sit
sir,
together and yeah. Yeah, hello?
after this like probably after the final exam only we will start with our projects.
Oh yeah, yeah.
So in that case also that will be really helpful, because our projects is totally dependent on like it is a MLP project after all.
Yeah, we can take the session. I mean, and also from this term also, I mean, if you guys want, then I mean, see, it's week 8, week 9, no, yeah, after the term only. I mean, yeah, that would be better. And yeah, if you guys have any questions like that, see, you can ask. I mean, directly just put the codes, or you can ask directly. I mean, yeah, yeah. Let's create. I mean, for 1 or 2 hours of content. I mean, you just say that yeah, this code and that code. Okay, and
Yes sir,
we can.
like we will create a summary kind of we will create a note, then
Yeah,
we will send it to you in your email ID.
yeah, yeah. That would be great. I mean, yeah, that would be better. I mean, see, the thing is like the basic problem what I feel. I mean, many times we think that yeah, these people that they can understand. Like here also, like see, this C map is nothing but just a color one. I mean, just it represents the color only, where it is set as gray. Okay, so basically why I referred that one. See, here also, I mean, see, PLT dot C, get C map. Okay, it just says talks about like which kind of color you want to use. Okay, I mean color mapping. It is
Yes
gray.
sir.
So I mean, yeah, let's say like I mean, it is like that only. I mean, 0 to 8, it is it will set the colors. I mean, yeah, more the numbers, more will be the numbers. It will I mean, it will color that in that. I mean, the lesser the intensity of that color. I mean, let's say 0 means if here we are setting that CMAP as gray. So it simply means that we will get a range of colors. I mean, we will represent the color, let's say 8 numbers. Okay, we will represent the gray color by numbers, which simply means that 0 number means the white color, 8 number means black color, and in where between the, let's say number the 7 is uh, uh, very dark color. Okay, and number 2 and 3 will means, I mean, a little gray color.
Okay sir, I get it. Like it is kind of a heat map that we use in Excel.
Yeah, exactly. It is kind of
Okay sir,
different.
like okay.
So,
And one last question sir, like this PLT dot axis at the last line
yeah, sorry.
of this PLT dot axis. Yes sir, this one, yes sir.
LT dot X off. Okay, so this one you are saying that what is visible. So what happens like when you plot anything? No, here it will give you the axis like X and Y axis lines. Okay, so if you will turn it off, no, then it won't give you that line.
Okay sir. Okay sir, it was really helpful sir, thank you.
Yeah. Okay, thanks. Yeah, I would also like to thank you, because yeah, that's why the session went some a little interactive. Otherwise, like people, I mean, if the session
Yes
doesn't,
sir.
Yeah, if the session
And
doesn't
also, like, I think people might have not seen all these videos and all. Like, it is
yeah,
they have. Yes,
that can
yes,
also be a reason. The thing is like when the
yes.
sessions doesn't get interactive, no, we also feel bored. We also feel bored. I think that I what I had thought like the session will go for like hardly 1 hour, but yeah, due to people only the
Yes,
session.
sir. Yes, sir. Yes, sir. Like, interaction will help us only. Like, it will be better for us only. Like, we can know many things in interaction.
Yeah,
Yes.
okay, okay,
Thank you, sir.
okay, okay. Thanks, Abhishek. Hi, Sandeep. I think
Thank you, sir.
yeah, Sandeep, you were not there in the session. I mean, I think
No, just join.
yeah. Sorry. Okay, yeah, because I think yeah,
Okay.
I didn't see you. At the last only I am able to see you. That's why I said. Okay, yeah. Bye, everyone. I hope.
No, actually, I just joined. I wanted to ask a few questions. I couldn't join. I was caught up with something else. So
Okay.
my question is, they use the Avalon dataset in the week 9
Avalon
demonstration code.
Yeah.
The problem with Avalon data is most of the features are highly correlated with each other, right? I mean, if you look at the
Actually, your voice is not that good, Sandeep. It's a bit big.
oh, can you hear me now?
Yeah, yeah, yeah.
Hello. Yeah, what I'm saying is there is a problem with Avalon dataset, which is that the features are highly correlated with each other.
Okay.
Right? Yeah, if you look at the correlation map, it's more than 90%. Most of the pairs have more than 90% correlation, 0.9 Pearson correlation coefficient. So,
Okay.
but the professor didn't do anything about that. It was just put to the pre-processing, and then the model was fit to this data. So in our, so I wanted to say in our practice, I'm an industrial engineer, and we practice Six Sigma. There is a process called Six Sigma which helps in
Yeah. 6
attaining process excellence, or reducing the number of rejections or rework which is coming out of the process. So in Six Sigma also we perform a lot of things where we have to be very careful about factors which are correlated to each other, which goes into a process. And there is a term called variation. There is a term called variation inflation factor.
Yeah. VIF.
VIF. Yeah. So we perform that operation and remove all the factors which are correlated with each other.
Yeah.
I mean, remove one of the factors. So are we going to do that kind of thing in machine learning also? Because I thought that the Avalon dataset really required a process like that to get rid of one of the features which are correlated with another feature. So that we could only.
Yeah, I got your point. That's true. I mean, it's completely perfect. And you know that VIF we also use in linear regression.
Yeah. We also use linear regression in Six Sigma or process excellence things.
Yeah. So here also, I mean, in ML also, like we use many times we use that VIF. I mean, we calculate after the training the model. Also, like we calculate the VIF, and we have libraries and all everything for that. And yeah, directly we calculate the VIF, and just by seeing that VIF values are like once it is going beyond the beyond the 5, yeah, or it depends on the I mean dataset. Like if sometime what we do that we just whatever the value we are getting, if we are getting 5 value greater than 5, we just remove that, and after that we cross check we again calculate the VI values, and yeah, whenever we are getting more than 5, we remove that, or sometimes we take the 10 also. So that's a different thing. And here I am saying that see, the main goal of the servers there in that collab was just to show that, I mean just to show that like the processes, like how these things work. Okay, so definitely it completely depends on the data set and all, that if the features are highly correlated, you should remove that. Okay, but in decision tree I would say that see here and the reason you also know that when if some features has when there are high correlation, no, so you should remove, because see if there is high correlation, then you will give more weightage to that term. Okay, I mean more weightage to that that particular feature. Okay, so did you got my point and whatever?
Yeah. I got your point, but are we going to cover this in the future lectures or future weeks of this course?
What?
Because I haven't come across this variation inflation factor thing.
So it is not covered, no? Yeah, actually, yeah, I had covered in the last time in week 4, I think I had tried whether I covered or not. I don't know. I mean, in the week 4, I had used that one. I mean, I tried solving that, or if you want, I can show you. Okay, it's not a big thing. I mean, I had
So-
collapse when I used to practice. I would have some collapse where I had done that. Okay,
So I put up a post on Discord to help you remind about this for the next.
Yeah,
next
that
live
will,
session.
that will be also fine. I mean, I will like to share you my collab. Okay, in one of the collab I had done that. Okay, I will show you. And basically, but I would suggest, see, what I am able to recollect. No, like in the last term only, in MLP week A4 in the SW I had made that, and I used that VIF to remove that features. But here in that collab, what had happened, like we got 2 features only at the end after applying the VIF. But I'm not sure whether in the session I described that or not, because I think the session were going for the long time. So yeah, I just skipped that. But yeah, when I had created that collab, yeah, I had used that. But I'll share that. Okay.
Okay, thank you very much.
Yeah. Thanks. Sir. Thanks, Ajay. Yeah. Bye all.